I'm going to go ahead and explain the difference between physical and chemical changes. Now, some people in class were getting a little bit confused about what the difference between properties and changes are. Properties, when we're talking about physical and chemical properties, those are just things that you observe. So whether or not you're changing the identity or not, you are an observer. And so the best way for me to explain it, when we're dealing with properties, it's you as a person, as a scientist, and you are observing, you're looking down on something, right? So if whatever that something is causing a change in the identity of the substance that you're looking at, then it's going to be a chemical change. If it doesn't change the identity of the substance, then it's a physical change. Now, physical property, my brain. Then, if we look at what exactly is happening, whether you're changing the identity of the substance or not, that is a physical or chemical change. So this is the change itself, whether it's physical or chemical, and then what you're watching, that's the property, what you see, what you're observing. So in the first example, sugar dissolves in hot water. Now, if you dissolve anything into water, unless it's reacting, it's going to be a physical change because you are not changing the identity of the substance. So it's going to be physical. Now, if I said sugar reacted with air to create, like, I don't know, burnt sugar, then I'm changing the identity of the sugar. A good way to think about this for a physical change here, if I dissolve sugar into water, I know that the sugar itself doesn't change its identity because I can then I can evaporate the water, or I can boil off the water, and what I'll be left with is the original sugar. So if I can get it back, it's going to be physical. 2, sugar burns in a pot, in a pot, that's going to be chemical. I'm changing the identity, it becomes black, I can't get it back, it's a chemical change. A metal surface becomes dull because of continued abrasion. So if you're scratching at something, you're not changing the identity of the metal. You're not having it react with anything. You are just scratching away at it. Think about abrasion being something like cutting, right? So if you cut someone's hair off, you're not changing the identity of the hair. It's still hair, but you've just changed the way it looks. With abrasion, if I'm scratching at something, then I'm not changing the identity, I'm just physically changing it. All right. Now for 4, if a metal surface becomes dull on exposure because of exposure to air, the air is having some sort of reaction with the metal. And so in this case, it's going to be chemical. So if it's clear that there's a reaction occurring, something chemical, right, something chemistry related, it's going to be chemical. If it's clear that it's just a physical change, somehow it's changing but there's no chemical reaction occurring, it's going to be physical. 5, several pieces of graphite are broken into tiny pieces. Again, it's going to be physical. I'm not changing the identity of the graphite. However, here, if I ignite it, if I catch it on fire, that's going to be chemical. So basically, if you're looking at something and you're like, I'm not sure if it's chemical or physical, if it seems really boring, like, I don't know, dissolving sugar in water, right? Or scratching away at a surface or breaking graphite, it's going to be physical. It's going to be a physical change. But if you're burning something or you are reacting it with air or you're catching it on fire, it's going to be chemical. And so what we're going to be studying in this class are just the chemical changes, not the physical ones, because the physical ones aren't really interesting. We're interested in the actual chemical reactions that occur. And that's it.